for JEE and Ioqm. So first of all, what is polynomial? Polynomial, an expression px equals a0 plus a1x plus a2x square plus a3x cube up to an xn, where n belongs to whole number and a0, a1, a2, an belong to the set of complex number, is called a polynomial. Example: px is equal to 2 plus 3x is a polynomial. Px is equal to 2 is a polynomial of degree 0. Degree of a polynomial is highest power of x in polynomial, right? तो इसकी डिग्री 0 है. डिग्री ऑफ दिस पॉलिनोमियल इज 1. px is equal to x square plus 3x plus 2. The degree of this polynomial is 2. px is equal to x square plus 2. The degree of this polynomial is also 2. So these all are example of polynomial. Px is equal to root x is not a polynomial because the power of x is not a whole number. Now, types of polynomials. We have different types of polynomial depending on the degree of polynomial. The polynomial with degree 0 is called 0 degree polynomial. Linear polynomial whose degree is 1. We have a quadratic polynomial whose degree is 2. We have a cubic polynomial whose degree is 3. Biquadratic and similarly polynomial is used for degree greater than equal to 5. Simply polynomial is used for degree greater than equal to 5. So with degree is equal to 0 we have px is equal to 2, that is constant. Degree 1 px is equal to x, or it can be px is equal to 2x plus 3 any. Px is equal to x square plus 3x plus 2. Px is equal to x cube 4x square plus 3x plus 1. These all are examples. Now with degree 4 we can write px is equal to x to the power 4 plus 3x cube plus 1. Here the coefficient of x square and x is 0. Now we have another classification of polynomials on the basis of number of terms. Like this is a polynomial containing two different dissimilar non-zero terms, right? This has a 2x and a 3. These both are dissimilar and these are two non-zero terms. So this polynomial is called binomial. this polynomial px is equal to 2 has only one term. This is called monomial, right? Similarly, we can classify that polynomials are of different types on the basis of number of terms, number of dissimilar terms, on the basis of number of non-zero dissimilar terms, right? Px is equal to x square plus 1. This is a binomial, right? Contains two non-zero dissimilar terms. Px is equal to 1, or Px is equal to x, or we can take Px equal to x square. These all are example of a monomial. Similarly, P of x is equal to x square plus 3x plus 2. This is an example of trinomial because it contains three non-zero dissimilar terms, and for greater than equal to 4 dissimilar non-zero terms, we have Px is equal to like x square plus x cube plus 3x square plus 2x plus 1. This is simply called polynomials for greater than equal to 4 non-zero dissimilar terms. We say simply polynomials. Basically, this is all about polynomial and its classification. Now, what is the meaning of a equation? Any expression equal to some constant, or it may be equal to basically we can say any expression equal to 0. It's called an equation, right? So if a polynomial px is equal to 0, and this is a polynomial of degree n. So this equation is called nth degree equation in x, right? So quadratic equation is formed when a polynomial of degree 2 equates to 0, right? So P2x is equal to 0. This is a second degree quadratic polynomial, we can say quadratic polynomial. This is called a quadratic equation. We can have example like x square plus 3x plus 2 is equal to 0, x square is equal to 0, x square plus 4 is equal to 0, 2x square plus 3 is equal to 0. These all are example of quadratic equations. Now we will study more about quadratic equation. The general equation of quadratic equation is ax square plus bx plus c is equal to 0. Now first of all, how to solve a quadratic equation, and how many roots does the quadratic equation have? What do you mean by roots? Roots is the value of x belong to the complex number set which satisfy the equation. Root can be real, root can be imaginary. We do not say about the nature of root, but we know that root is something, some value of x which is satisfying the equation. Now we will finding the roots of this quadratic equation. If this is a quadratic equation, then obviously a is not equal to 0. Yes, if in question it is given that this is a quadratic equation, then we assume that a is not equal to 0. But if in question it is given it is just an equation, then a can be 0, and you have to consider that case separately. So here a is not equal to 0, so we can solve. The method 1 to solve the quadratic equation is basically x square plus bx, ax square plus bx plus c is equal to 0. Divide by the coefficient of x in the step 1 like this is equal to 0. Now we can see this x square plus 2 times b minus a into b by 2a into x plus c by a. Now add b square b by 2a whole square and subtract b by 2a whole square, and this is equal to 0, right? Now club these terms. When we club these terms, we get x plus b by 2a whole square plus c by a minus b by 2a whole square is equal to 0. From here, x plus b by 2a whole square is b square minus 4ac by 4a square. So x is minus b plus minus root b square minus 4ac upon 2a. So from here we can see that we get two roots of quadratic equation. We get two roots of quadratic equation, right? So a quadratic equation have exactly two roots. Now method 2, and note that if b square is equal to 4ac, then x is equal to minus b by 2a. So we get only one solution, then it should be only one root, but it is not true. The quadratic equation always have two roots. The roots can be equal and or unequal. Here in this case, when b square is equal to 4ac, the two roots of quadratic equation coincide. So we say that the roots are equal, right? We say that the roots are equal. But this quadratic equation will be having two roots, minus b by 2a comma minus b by 2a. Method 2 to solve quadratic equation is factorization. For this we are taking an example like x square plus 3x plus 2. Now we have to express this middle term as a sum of any two factor of the multiplication of coefficient of x square and the constant term, right? So the product of coefficient of x square and coefficient of a constant term is equal to 2, and the factor of 2 is 2 into 1. So we express this as a sum of these factor. 3 as a sum of these factor can be expressed as like this. Now we take x common, x plus 2, and this is x plus 2. Now from this whole expression we take x plus 2 0, x plus 2 common, and now if this quantity is equal to 0, then either this term is equal to 0 or this term is equal to 0. So either x plus 2 is equal to 0 or x plus 1 is equal to 0. So x is equal to minus 2 or x is equal to minus 1. We have two roots of this quadratic equation, minus 2 and minus 1. Let's take another example. X square minus 4x plus 3 is equal to 0. The product of these factors are the product of coefficient of x square is 1 and constant term is 3 and the product is 3. So 3 is 3 into 1. So we write this x square minus 3x minus x plus 3 is equal to 0. We should notice that the first term we write when we express it as a sum or difference of factors, right? We can express the middle term when it is factorizable as a sum or difference of the product of constant and the product of coefficient of x square. So the first term should be matching with the coefficient of x, like there is plus 2, the sign of this term is plus, so the sign of 3 is also plus. Here the sign of 4 is negative, so we start with a negative coefficient, right? Similarly, so we take x common, x minus 3 minus 1 common, x minus 3 is equal to 0. So x minus 3 into x minus 1 is equal to 0. Now if this quantity is equal to 0, then either this term is equal to 0 or this term is equal to 0. So x is equal to 3 or x is equal to 1. So these are the methods of factorization of quadratic equation. Now we come to the third method of solving quadratic equation. This is a ready-made formula called Sridharacharya formula. So we can learn it. Ax square plus bx plus c is equal to 0. We have just solved by method 1 and we got this result. X is minus b plus minus root b square minus 4ac upon 2a. So we will be learning this result. This is the method 3. So x is equal to minus b plus minus root b square minus 4ac upon 2a. So this b square minus 4ac is called discriminant of quadratic equation, right? Why we say this as a discriminant of quadratic equation, we will study it later in the theory of equations in nature of root sections. Now we have to learn this, that this is the Sridharacharya formula. Or by quadratic formula. Now we will come to the definition of an identity in X. Identity in X. An identity in X is an equation which is satisfied by all x. It is satisfied by all x. So let's take an example. P of x is equal to 2. This is an identity satisfied by all x, which means that x can be 1, 2, 3, and it can be iota, 2 iota, 3 iota, any. But the value of p of x for every x is equal to 2. So this is an identity. Let's say p of we have an identity that x plus 2 whole square is equal to x square plus 4 plus 4x. This is also an identity satisfied for all x, right? For all x belong to the set of complex number, right? This is a identity. Now what is the use of identity in question solving? Like if ax square plus bx plus c is equal to 0 for more than 2 values of x, then a equal to b is equal to c is equal to 0. For more than 2 values of x, then a is equal to b, c is equal to c is equal to 0. How we can say this? Let's see. Now this quadratic equation it has exactly 2 roots. This quadratic equation has exactly 2 roots. If it is satisfied for more than 2 values of x, 2 values means more than 2 different values of x, right? If it's satisfied for more than 2 different values of x, then it cannot be a quadratic equation, which means a should be is equal to 0. If a is equal to 0, then it becomes a linear equation in x, and a linear equation in x can have maximum one root. So if it has more than two values of x satisfying it, so it cannot be a linear equation. So b is equal to 0 and c is equal to 0, right? If a is equal to 0, b is equal to 0, then c must be equal to 0. So this is an identity theorem which can be used in questions. Let's see. Now we will be discussing an other definition of identity that is at a higher level. For any identity, what is the difference is that an identity may not be true for all x in complex number. It may be true for a range of x. So we are defining the combined definition, the final definition of identity. Identity is if a statement is true for all values of variable under domain of a statement. Domain is the acceptable values in that statement. Then it is called an identity and has infinite solution. Right? So domain is like a range of values of x that we can put in that expression. Like x plus y is whole square is x square plus y square plus 2xy. This is identity true for all pairs of x comma y. So the pairs of x comma y here is called domain of this equation. Now we have taking a question that if x minus a upon b minus a plus x minus b upon a minus b is equal to 1 is an identity, then prove that हमें ये प्रूव करना है कि एक आइडेंटिटी है, ये इक्वेशन एक आइडेंटिटी, वी हैव टू प्रूव दैट, राइट? प्रूव दैट दिस इक्वेशन इज एन आइडेंटिटी. So let us start. Now what is the aim? Our aim is we have to prove that this is satisfied for more than two different values of x. If we are able to prove that, then by identity theorem we can say that this equation is an identity in x. So P of, well, put x is equal to a. Put x is equal to a. X equal to a satisfy this equation. Put x is equal to b. X equal to b satisfy this equation. Put x is equal to, basically this is a we have to prove that this equation is identity in x. So this equation we can see it can be maximum have a 1 degree of x, so it can be a linear equation or it can be a 0 degree equation. So this can have maximum one root, but we can see that x equal to a and x equal to b satisfy this equation. So this equation have more than one root, which is only possible when it is an identity. So we have proved that this is an identity and the coefficient of x is 0 and the constant term is 0. Now coming to the next question. show that x minus a into x minus b upon c minus a c minus b plus x minus b into x minus c upon a minus b into a minus c plus x minus c into x minus a upon b minus c into b minus a is equal to 1 is an identity in x. So we put x equal to a, so we get on left hand side this term will be 0, this term will be 0, and we get 1 is equal to 1. So x equal to a satisfy x is equal to b. When x is equal to b, this term is 0 because it has x minus b, this term is also 0. We get b minus c into b minus a upon b minus c into b minus a, so we get 1 is equal to 1. So basically x barabar a satisfy this equation, x barabar b satisfy this equation. Now we put x equal to c, we get this term is 0, this term is 0, and c minus a into c minus b, which cancel out since we are given that a is not equal to b is not equal to c, as they cannot be equal, b minus c, b minus a, all these terms are in denominator. So for defining this equation we must have this condition. So at x is equal to c, this term will be 0, this term will be 0, this term will be c minus a into c minus b upon c minus a divided by c minus b. These all will be cancelled out, so 1 is equal to 1. So this equation, we can say the power of this equation, the degree of this equation is 2, so it can have maximum 2 roots which can satisfy. But as we can see, more than 2 different values of x satisfy this equation, so it is an identity in x, meaning that the coefficient of x square, x, and the constant term in this equation is 0. Now find the possible values or real values we are talking of p for which p square minus 3p